Hi, my name's Kevin Henney. I'm based in Bristol, where the sun is actually shining. I wanted to talk about experiments, specifically thought experiments. Normally when we're making decisions, we rely on our experience. Sometimes that's a good thing, sometimes that's not enough. And there are a lot of assumptions around our own experience, and perhaps we draw on the experience of other people. But that's relying on something that can, in theory, be known based on what is in the world now. Sometimes when we're making decisions, we can't decide between option A and option B. Maybe that's two different architectures, maybe it's two different programming languages, two different user interfaces, two different software choices. And in that case, we're not sure. So we can solve this. This is not an insoluble problem. We can guess, which is what a lot of people often end up doing, for better or for worse. But we can do better than guessing. We can actually run an experiment, an actual experiment, and try out A and try out B and see which one works better for us. Quite literally, when it comes to different product UIs, we call it A/B testing. So you can actually run an experiment and get real data and interpret it how you will. But sometimes there's value in looking at a different kind of experiment. And this is a kind of experiment that was popularized by Einstein. Albert Einstein kind of led him to the theory of special relativity, and he published 4 significant papers in the year 1905, which is referred to as his Annus Mirabilis. And in this marvelous year, he redefined modern physics. The one that stands out most and is relevant here from a thought experiment point of view, a Gedankenexperiment, is special relativity. Normal relativity is, let's say I'm running at 10 kilometers per hour and I have a ball, which I don't, maybe I have a phone, and I throw my phone, I won't do that, and I throw it at 20 kilometers per hour. I'm running at 10 kilometers per hour. The actual velocity of the object that I've thrown is now 30 kilometers per hour, 10 plus 20. That's normal Newtonian relativity. That's great, that works really well, except for one small thing, and this is what Einstein was grappling with, was this issue of the speed of light. James Clerk Maxwell had categorically demonstrated that the speed of light is constant for all observers. Now, how does that work? I mean, if I'm travelling at the speed of light and then I shine a torch, doesn't the light go at twice the speed of light? Well, that can't work, because... So really what he did is he ran a thought experiment and demonstrated that one of our fundamental Newtonian assumptions, the constancy and universality of time, that everybody experiences time the same, doesn't hold. For something to have apparently the speed of light, or for light to have that speed, for all observers requires that we mess with time. And that came about as a byproduct of a thought experiment. Now, we can also use thought experiments in software development, where we can actually break the laws of physics rather than demonstrate them. So, the great thing about thought experiments is they're incredibly cheap to run, and they're really just what-ifs. They allow us to take things to extremes and understand the boundaries of ideas, but also to illustrate sometimes hidden motivation or hidden issues. So let's talk about breaking the laws of physics. So one thought experiment I ran years ago, these are just verbal, was simply for a company that I visited them one year, and I'd asked them how frequently they were releasing, what's their release tempo, and they said once every 3 months. The idea that they could do it any more frequently seemed like heresy to them. We didn't focus on that at that point. They had a number of other issues. I visited again a year later. The development practices were greatly improved, all kinds of improvements, and I asked them again, how frequently do you release? They said once every 3 months. And then I said, I want you to imagine, here's the thought experiment, imagine you could develop at infinite speed. Okay? What that means in practice is, if you develop at infinite speed, it means everything takes 0 time. You request a feature, done. Did you write the documentation? Done. Did you write the test? Done. Everything takes 0 time. At that point I said, okay, imagine you can develop at infinite speed. How frequently could you release? After a moment's pause, once every 3 months. In other words, the bottleneck's not you. The bottleneck is somewhere else. It turned out it was another department who was doing manual testing. Guess how long it took? about 3 months. Actually, it took longer, but 3 months is all they were ever given. So the point there is that by demonstrating something extreme, you might be busy trying to focus on your practices. Somebody might think, oh yeah, you're the bottleneck, or you might be thinking you're the bottleneck. But when you come down to it, it's actually no. If we were to develop at infinite speed, which is clearly not physically possible, that thought experiment demonstrates that the problem is elsewhere. At that point, you can start talking lean, theory of constraints, and all kinds of great stuff. Okay, another simple thought experiment. Why do we prioritize things? Whether it's requirements or bug fixing or anything like that. Why do we prioritize? It's kind of a given. People have all kinds of thoughts about why they spend time prioritizing things, why things in Jira have priorities, why things on a whiteboard have priorities, why the backlog has priorities, why all of this stuff has priorities. It's just a given assumption. Well, let's question that assumption. That's the whole point of a thought experiment. I want you to imagine that we've got a number of things we need to do, and we've got a certain amount of time, T, in which we can do them. But to do anything takes 0 time. Do we need prioritization? No, because we're done in an instant. Okay, that was easy. Okay, so let's step this up a little bit. Let's make sure that everything now takes non-zero time, but that the total amount of time to do all the things that we have listed, the total amount of time is going to be less than or equal to time t, which we have available. So we're going to get everything done, aren't we? What is the role of prioritization? Well, prioritization is quite simply preferential ordering. When do we want things in time? There's no business case for anything. It's just it's a preference of ordering. Maybe there is a business case for some things, but the idea is you could do it in any order and you would still finish within the allotted time. So in one sense, we could say that our ordering is arbitrary. There is no strong reason why we'd have to choose one order over another. That would be partly subjective, or bringing things from other contexts to make the decision. Okay, now let's revisit that one and make sure that the total time is now greater than the time available, time t. So now, what is the role of prioritization? The role of prioritization is to determine what will get done and what will not get done. Because there's a whole load of things that are going to get done if they are of high priority. Remember, priority is about ordering at one level or another. So we're actually saying the reason we prioritize is to determine what we're not going to do. And that's a bit of a shock, because many people come up with very sophisticated numbered schemes and things like that. There are only in truth 3 priorities. There is, we're going to do it now, we're going to do it later, we're not going to do it. That's the 3 priorities. That's it. All priority schemes in practice boil down to this. And that's the reason that we do this, because we do not have enough time to do everything. We are swamped. All prioritization schemes, in this sense, you might say, well, hang on, Kevin, I don't have a fixed time T. We've got a lot of time. We have an abundance of time because we're always developing software. Software is not a project, it's an ongoing product development. Yeah, but for everything that you fix, there is now something that comes in. You're in steady state. If high priority things are replaced at the same rate, what that effectively means is if prioritization is the sole way that you determine what you're going to work on next, then what you have is what we call an unfair scheduling algorithm. You are guaranteeing that anything that is a low priority will not get attended to. Okay? It's a basic denial of service. And companies accidentally do this. They actually classify bugs that will never get fixed because we must always work from the highest priority downwards. They never work on low priority features. And things that often get deprioritized, working on technical debt, does that sound familiar? Those never get done. What you've done is you created a system that guarantees you will not do certain work. People don't want to hear that because they like the optimistic idea that one day they will be able to do it. Of course, that's a thought experiment. If I had infinite time, of course you'd be able to do it. So this is the point. What you've done is you've explored the fact that in practice, prioritization exists because we have more work to do than we have time available. That is the problem you need to solve. Don't embrace it and make something complex. Figure out that's the real problem. The problem is not what priority scheme do we choose, is how do we free ourselves from the constraints of a priority-based system. So that's just a simple example of the kinds of thought experiments that we can run. turn the dials to 0 or infinity, see what happens. So next time you are confronted with a decision for which you don't have sufficient experience, or you cannot easily run an experiment in reality, I invite you to give it some thought.